Before rockets rose, the question was simple. Could one nation turn ambition into a permanent path to the stars? In the late 1950s, that question landed in Washington with unusual urgency and historic consequence. The United States had talent, laboratories, and aircraft expertise, but no single civilian space command. Then Soviet victories in orbit changed the tempo of history and forced America to reorganize fast. On July 29, 1958, a new agency was signed into existence, NASA. It opened for business on October 1st, built from America's Aeronautics Foundation, and aimed far beyond the atmosphere. NASA was founded to unify civilian space research, accelerate innovation, and keep the United States scientifically competitive. What followed was not one mission, but a system designed to outlast headlines and generations. The first years were about learning the basics: launch, orbit, survive, return, and improve. Mercury proved Americans could reach space at all, a crucial first step in a dangerous era. Those early flights were short, risky, and imperfect, but they turned uncertainty into experience. Gemini taught rendezvous, docking, and longer missions, the skills Apollo would desperately need. Behind every astronaut stood an industrial machine of engineers, machinists, mathematicians, and test crews. NASA was no longer improvising. It was building capability at national scale. Then came Apollo, one of the boldest technical programs ever attempted by any government. In July 1969, NASA placed humans on the moon and changed history forever. The achievement was symbolic, but it was also scientific, operational, and profoundly technological. The whole world watched, and for a moment, space exploration became a shared human event. But progress was never smooth. Failure, loss, and redesign were built into the price of leadership. The Space Shuttle then opened a new chapter. Repeat access to orbit and more complex missions. It carried satellites, laboratories, interplanetary hardware, and the experience needed for orbital construction. One of NASA's greatest gifts to science arrived in 1990, the Hubble Space Telescope. Hubble transformed astronomy, revealing galaxies, stellar nurseries, and a universe far richer than expected. Even its repair missions became proof that persistence can rescue visionary engineering. NASA also pushed outward. Voyager explored giant planets with a reach no mission had matched. Voyager 1 later crossed into interstellar space, still sending whispers from beyond the sun's protective bubble. Mars became another proving ground, where rovers turned a distant world into a field site. From dust to drilled cores, NASA began collecting evidence about ancient environments and possible past habitability. Across the outer solar system, robotic explorers widened humanity's map of what worlds can be. Every mission added data, but also capability, navigation, communications, autonomy, and survival in the unknown. In low Earth orbit, the International Space Station became a laboratory that never truly sleeps. There, NASA helped turn spaceflight from brief visits into continuous research and long-duration human living. The station also showed another truth. Leadership does not exclude partnership. It often depends on it. In the 21st century, NASA reshaped its model by working more deeply with private industry. That partnership helped lower launch costs, increase cadence, and accelerate experimentation across the sector. It also restored the ability to launch crews from American soil using American commercial systems. Then came Webb, a telescope designed to look farther back in time than Hubble ever could. Its images did more than impress. They changed how scientists study the early universe. Now NASA is turning again toward the moon through Artemis and the wider Moon-to-Mars strategy. This time, the goal is not just arrival. The goal is sustained presence, science, and preparation. Heavy-lift rockets, deep space capsules, landers, and surface systems are all pieces of that architecture. Around the moon, new infrastructure could make deep space operations more routine and more ambitious. So why is the United States still widely seen as the leading space power? Because NASA sits inside a larger ecosystem: universities, national labs, contractors, startups, and test ranges. Because leadership in space is not one launch, it is decades of repeatable performance. Because American commercial space grew beside NASA, not apart from it, multiplying national capacity. Because space leadership is measured not only by prestige, but by useful science and practical impact. Weather forecasting, climate tracking, navigation, communications, and disaster response all draw from space research. Other nations are formidable and rising fast, each with major strengths and serious accomplishments. But the United States still leads in combined scale, science, funding, launch activity, and industrial depth. That lead endures when institutions can train talent faster than missions consume it. It endures when hardware can be tested, rebuilt, and launched again across many parallel programs. And it endures when ambition survives elections, setbacks, and changing generations of technology. NASA's story is not simply American pride. It is organized curiosity with national backing. Its greatest long-term product may be inspiration, millions choosing science, engineering, flight, and discovery. Yet the true output is deeper than inspiration. It is knowledge that becomes capability. The next era may include long stays on the moon, new industries, and permanent off-world operations. Beyond that horizon waits Mars, still distant, still difficult, and still irresistible. From Apollo to Webb, NASA's record shows how leadership compounds when institutions keep learning, and every journey outward keeps returning value to the planet where the journey began. None of this came free. Exploration has always demanded risk, discipline, and sacrifice. But again and again, NASA turned those costs into knowledge shared across the world. That is the deeper reason its legacy matters. It keeps expanding the human possible. NASA began in urgency. It endures because the frontier still moves, and someone must keep going.